Hello friends, I Dr. Padmini Sharma welcomes you all to Swayam online course on maintenance and testing of electrical machine. In the previous class, we have gone through the different transformer protection technique. Since transformer is a static device, so occurrence of fault is very rare, but if it occur, it take more time and money as compared to other electrical equipment. In previous lecture, we started our discussion with the Buchholz relay, which is gas actuated relay and used to protect transformer against various incipient fault such as insulation failure of winding, core overheating. Buchholz relay sound an alarm for slow developing incipient fault and disconnect the transformer from the power supply in case of severe internal fault. Then we have discussed the working principle of earth fault relay, which offer protection specifically against the earth fault. Next, we have covered combined protection technique for both leakage and overload condition. The earth relay is set to a low current value and only respond to the earth or leakage fault. On the other hand, overload relay are set to a high current value and are designed to activate when there are fault between the phase. The trip contact of overload relay and earth fault relay are connected in parallel. So, when the fault occur in any of the section, the relay is tripped. Next, we have discussed about the differential protection, which is widely used for transformer protection due to its high reliability and sensitivity in detecting internal fault such as phase to phase and phase to ground fault. It works on the principle that under normal operating condition, the current entering the transformer should be equal to the current leaving it. Any difference between these currents indicate a fault within the transformer. Although the differential protection provide the best overall protection, but some factors such as CT saturation, CT characteristic mismatching, inrush current or CT connection affect the differential current performance. So, while considering the differential protection, these factor can be considered. Otherwise, these factors can result in a differential current even under balanced power in an out condition. Next one is the percentage differential protection technique, which is the advanced form of the differential relay, is used to overcome some of the difficulty faced by simple differential relays such as mismatched CT characteristics, etc. So, percentage differential protection scheme using the restraining coil. And restraining coil also. So, it included two coil, operating coil and restraining coil. When the torque developed by operating coil is greater than the restraining coil, in that particular condition only the relay responds. So, this is all about the previous classes. Now, in same series, today we will going to cover some of the important protection technique which is we apply for the transmission protection. Let us start today's discussion. A transmission line carries electricity from a producing substation to the various distribution unit. It transmits the voltage and current wave from one end to the other. The transmission line's conductor has a constant cross section of the whole length of the line, where air function as a dielectric or insulating material in between the conductors. For safe reason, the line is considered farther from the ground. The electrical tower supports the transmission line's cable. The tower is made of the steel which give the conductor a tremendous amount of strength. Transmission lines are a vital part of electrical distribution system as they provide the path to transfer power between generation and load. Transmission line can vary in length from several hundred feet to several hundred miles, and also see the variation from in line to line voltage from 66 kilovolt to 750 kilovolt. The overhead transmission line has a greater fault incidence rate than the other crucial component of electrical power system. Why? Because it is mostly exposed to the ambient condition and their greater length. Fault in the transmission line are abnormal conditions that disturb the normal flow of electrical power. This fault can cause significant damage to electrical system, lead to power outage and pose safety risk. Hence, fault in a transmission line is a crucial aspect of power system management, requiring carefully planning, monitoring and response to ensure reliability and safety. Next, we are going to discuss about what are the various causes for transmission line fault. First one is the over voltage because of the switching surge, lightning effect, insulation breakdown, and because of the more external and internal stresses on the conductor, falling of tree on the transmission line, heavy rain, snowfall and wind, perching of bird, accidental short circuit because of string or snake, accident of vehicle with pole of transmission line or tower, and the chemical pollution. So, due to these all factors, the fault occur in a transmission line. Now, we covered what are the different techniques which we used for transmission line protection, and how we, and due to this discussed factor, what are the various type of fault actually occur in a transmission line. Transmission line fault are traditionally divided into two categories: series or open circuit fault and shunt and closed circuit fault. Each fault have the different characteristic and impact on the power system. Let's explore these categories and their subtypes in detail. First one is the series or open circuit fault. Series fault occur when there is an interruption in the continuity of the transmission line, such as break in one or more conductors. Series fault cause an abnormal shift in phase voltage. When one or more phases are open, the load becomes unbalanced, causing the voltage to deviate from their normal values. Next one is the shunt or closed circuit fault. Shunt fault involve a short circuit condition where a conductive path is established between the phase or between the phase and ground. This fault causes abnormal current flow and can be further divided into symmetrical and asymmetrical fault. So, shunt fault ko we categorize shunt fault into symmetrical and symmetrical fault. What is the symmetrical fault? These are fault where all the three phases are equally affected. They are less common but more severe. Since all phases are equally affected, it is called as a symmetrical fault. Symmetrical faults generate very high fault current which can damage the equipment if not cleared promptly. Under that, three-phase fault is covered. All the three phases are short circuit together or to the ground. It is most severe type of fault, but it occurs rarely. Next one is the asymmetrical fault. These faults involve one or two phases and are more common but less severe compared to the symmetrical or three-phase fault. Under that fault, first one is the single line to ground fault, or we can say LG fault. Under that, one phase come in contact with ground. It is the most common type of fault in a transmission line. Second one is the line to line fault, or we can say double L fault. Two phases come in contact with each other without involving the ground. Third one is the double line to ground fault or double LG fault. In that case, two phases come in contact with each other and the ground. So, the protection of line present a problem quite different from the protection of substation apparatus such as generator, transformer and busbar. Transformer protection system are designed to identify the location of fault and isolation only the faulty section. Some of the specific requirement of the transmission line protection are: first is the ability of protection system to isolate only the faulty section of the network. In the event of a short circuit, the circuit breaker close to the fault only open so that all the other circuit breaker remaining closed, which maintain the continuity of supply. Second one is the presence of additional protection system to take over if one is fails. It means that in case the nearest breaker to the fault fail to open, backup protection should be provided by the adjacent circuit breakers. Third and important one is the relay operating time should be just as short as possible in order to preserve system stability. So, these three are the basic requirement for transmission line protection system, which included backup protection, duration of relay operation is very less, and as well as the relay which circuit breaker relay which is connected very near to the fault that operate only. Next we discuss about the type of protection technique. Transmission line protection technique can be broadly categorized into unit or non-unit protection. Each type serves specific purpose and it is selected based on the requirement and characteristic of transmission line. Our protection technique into two categories, unit and non-unit. Under the unit protection scheme, it provides protection to a specific section of the power system such as transmission line or transformer by comparing measurement at both ends of the protected section. This scheme are highly selective and quickly identify fault within the selected area. Pilot wire differential protection and carrier current protection are come under the category of unit protection. Next one is non-unit protection of transmission line. Non-unit protection cover a broader area and it is designed to protect the transmission line without being confined by a specific zone. It typically provides backup protection and may operate for fault both within and outside the primary protected area. Time graded overcurrent protection and distance protection are come under the category of non-unit protection. Now we discuss the each protection scheme one by one. We start from the time graded overcurrent protection, which is the non-unit type protection scheme. Time graded overcurrent protection is a method to protect transmission line by coordinating the operation of protecting device so that the device close to the fault operate first, minimizing the impact of the fault on the power system. This technique or this is achieved by setting the time delay for each protected device in a sequence, with the time delay increasing as we move further away from the source to load. The goal is to isolate the fault as close to the fault location as possible, minimizing the outage area and ensuring the rest of the system remain operational. So, how it work? Protective relay are installed at various points along the transmission line. Each relay is associated with a circuit breaker. When a fault occurs, the relay detects the overcurrent and send a signal to corresponding circuit breaker to open and isolate the faulty section. Time graded protection of a radial feeder can be achieved by using definite time current relay and second one by using inverse time current relay. Definite time overcurrent relay are used by adjusting the operating time of a relay in increasing order from the far end of the feeder to the source. When faults occur, it starts a timing unit that trips the circuit breaker after a preset time independent of the fault current. The difference in the time setting of two adjacent relay is usually kept as 0.5 seconds. This difference is to cover the operating time of the circuit breaker. The time of operation of each relay is fixed and is independent of the operating current. Figures show the overcurrent production of a radial feeder by definite time relay. The relay C has a operating time of 0.5 second, while the other relay having time delay is successively increased by 0.5 second. when a fault occurs beyond C, relay of all section come into action. It means fault current flow through the all of them. But relay placed in a section C has a least time setting, so it operates after 0.5 second and the fault is clear. Once fault is cleared, relay of section A and B are reset. But when relay of circuit breaker of section C fail, it means fault remain uncleared. In this situation, after 1 second, the relay of section B operate that trip the circuit breaker of section B will trip somehow. But if the circuit breaker of section B also fail to operate, so after 1.5 second, circuit breaker of section A trip the relay. Time graded overcurrent protection scheme is preferred where the impedance between two substations is low. It means fault current is practically remain constant when fault occur on any section of the feeder. So, by using this technique, we with the help of time delay, we are designed in such a way that the faulty portion is only open at the time of fault and remaining relay provide the backup of that section. So, first advantage of is the selective isolation. Only the faulty section of the line is isolated, reducing the impact on the overall system. Second one is the simplicity. The method is straightforward and widely used, particularly in radial system. Next one is the cost effective. This method requires fewer sophisticated devices compared to differential protection or distance protection. But this system also having the disadvantage. The disadvantage of this system is that if there are a number of feeder in series, the tripping time for fault near the supply and become high. In that case, we have taken 2 seconds. However, in most cases, it is necessary to limit the maximum tripping time to 2 seconds. This disadvantage can be overcome by reasonable extent by using the inverse time relay, which will operate inversely with respect to flow of fault current. Next important protection technique is the distance protection technique. Distance protection is again a non-unit system of protection. It commonly used for transmission line where the fault are more likely to occur due to the high voltage and current level. It is a reliable and fast acting from a protection capable of detecting fault quickly and accurately, which help to minimize damage to the power system and prevent power outage. Distance protection is not affected by the type of fault. Since it protects a certain length of transmission line, it is called as a distance protection. The time graded protection are not suitable for protection of very long high voltage transmission line. It gives an excessive long delay in fault clearance at the generating station and when there are more than 4 or 5 sections, which we already discussed in previous section. So, distance relaying is applied for faster protection. Distance relay come in various types based on their operating characteristic and the shape of their impedance measurement zone on the resistance reactance plane or RX plane. According to the length of transmission line, different type of distance protection technique is used. Actually, distance relay is categorized into 3 categories: impedance relay, reactance relay and mode relay. So, according to the length of transmission line, we use such type of relay. When the length of an overhead transmission line is up to about 50 km and the line voltage is comparatively low, it is usually considered as a short transmission line. And for protection of short transmission line, reactance type distance relay is used. And when the length of a overhead transmission line is about 50 to 150 km and line voltage is greater than 20 kV to less than 100 kV, it considered as a medium transmission line, and suitable distance relay for medium transmission line is the impedance type distance relay. Next one, when the length of an overhead transmission line more than 150 km and line voltage is very high, above 100 kV, it considered as a long transmission line and more type distance relay suitable for long transmission line. So, according to the length of transmission line, we apply the distance protection technique. How the distance protection technique is work? Here we discuss about the impedance type distance protection technique. So, impedance type distance protection measure the impedance between the relay location and the point where the fault is incident and compare it with the set value. If the measured impedance is less than the set value, the relay operate and isolate the faulty section. Since the line impedance is directly proportional to line length, so we get the exact location of fault in kilometers. Since the input quantity to the distance relay is voltage and current and the output quantity is V by I, which is the impedance. So, this reliability of this distance relay is more as compared to overcurrent relay, which is based only the single input quantity, that is the current. For understanding the proper working of impedance type distance relay, we consider a simple system consisting of line in series such that the power can flow from left to right. The relay at A, B and C are set to operate for impedance less than Z1, Z2 and Z3 respectively. Suppose a fault occur between the substation B and C. The fault impedance at the power station and substation A and B will be Z1 plus Z for A and Z for B. It means Z1 plus Z impedance measured by the relay which is located at A point and Z impedance measured by the relay which is located at B point. So, it is clear that the portion shown only the relay B will operate because relay B is set for Z1 impedance, but here it measures the Z which is less than Z1, Z2. So, only the relay B will operate. Similarly, if fault occur within the section AB, then in that case only the relay operate at A point, because in that case relay A is set for impedance Z1. But if the fault occur between the AB section, so it measure the impedance which is less than Z1, that is why relay A is only operated. So, in this manner instantaneous protection can be obtained for all condition of operation. But in actual practice, it is not possible to obtain instantaneous protection for complete length of line due to inaccuracy in the relay element and instrument transformer. Thus, the relay A would not be very reliable in distinguish between a fault at 99% of distance AB and one at 101% of distance AB. So, these difficulties overcome by using 3-zone protection scheme. Generally, we use 3-zone distance protection scheme. Under the zone 1, it typically set to cover 80 to 90% of protected transmission line. This ensures that relay only detect fault within the majority of line. It protects, avoiding overreach into the adjacent line. Instantaneous operation with no intentional time delay is done under the zone 1, and zone 1 provide fast protection for fault occurring close to the relay. Then zone 2 set to cover the entire length of protected line plus 20 to 50% of next adjacent line. This zone provide backup protection in case of primary protection. Usually zone 1 is fail. It operates with a short time delay, typically 0.3 second to 0.5 second, and to allow zone 1 relay to clear the fault first. Zone 2 clear the fault of zone 1 fails, or if the fault is beyond the reach of zone 1. So, zone 1 is designed with a backup protection for a zone 1, and if the fault occur beyond the reach of zone 1, then only the zone 2 relay operate. Third one is the zone 3. We divided whole section into 3 categories, zone 1, zone 2 and zone 3. Under the zone 3, element provide backup protection in the event a fault in next section is not clear by its breaker. Zone 3 is typically set to cover 120 to 150% of second line. Operate with a longer time delay, typically 1 to 1.5 seconds. Zone 3 serve as a backup for Zone 2 and provide protection for severe system disturbance or fault on a adjacent line. So, there are many advantages of this zone protection of distance relay. First one is the selectivity. Each zone is carefully defined to ensure that the correct section of the line is isolated, minimize unnecessary tripping. Second is the speed. Zone 1 provides fast instantaneous protection for the majority of protected line, ensuring quick fast clearance of fault. Third is the backup, which is provided by Zone 2 and Zone 3 and reliable backup protection, ensuring that faults are clear even if the primary protection fail. Next is the flexibility. The reach and the time setting of each zone can be adjusted to suit different system configuration and requirement. After that, we covered about the differential pilot wire protection, which we already used in a transformer protection. Differential pilot wire protection is a type of protection scheme used for high voltage transmission line, particularly short line or feeder. It provides fast and selective protection by comparing electrical quantity, usually current, at both ends of the protected section. The scheme used pilot wire as a communication link to transmit information between the relay at either end of the transmission line. The fundamental principle is based on comparing the current entering and leaving the protected section. We already know that. Under the normal condition, the sum of current entering the section should equal to the sum of current leaving it. As soon as the fault occurs between the two ends, this condition no longer holds and the difference of incoming and outgoing current is arranged to flow through a relay which operates the circuit breaker to isolate the faulty line. Also, but if a fault occurs outside the protected section, the current at the end of the line still balance and the relay does not trip. So, it provides a unit protection. There are several differential protection pilot wire scheme available for transmission line. Here we cover the merge price voltage balance system for differential protection. Figure show the single line diagram for merge price voltage balance system for the protection of a three-phase line. Identical current transformer are placed in each phase at both ends of the line. The pair of CTs in each line is connected in series with a relay in such a way that under normal condition their secondary voltage are equal in opposite. It means they balance each other. Under healthy condition, current entering the line at one end is equal to the current leaving it at other end. Therefore, equal and opposite voltage are induced in the secondary of CT at both ends of the line, so that the no current flow through the relay. Suppose in balance condition, suppose a fault occur at point F on the line as shown in figure, this will cause a greater current to flow through CT1 as compared to CT2. Consequently, their secondary voltage become unequal and circulating current flow through the pilot wire and the relay. The circuit breaker at both ends of the line will trip out and faulty section will be isolated. With the help of merge price differential protection scheme, we can easily remove the faulty section from the part of the remaining element. This system, merge price protection system, is used generally for ringman as well as the parallel feeder. The system can detect even small internal fault, ensuring quick isolation of faulty section. This system provides instantaneous protection for ground fault. This decreases the possibility of these faults involving other phase. This system provides instantaneously relaying, which reduces the amount of damage to overhead conductor resulting from the arcing fault. So, these are the advantage of merge price protection, but it has limitation also. First one is the proper functioning of system totally rely on the exact matching of the CT at both end of the line. This problem we already seen in the differential protection of transformer. Second one is a break in the pilot wire circuit will cause the system to fail to operate. The system is costly due to the extensive length of pilot wire required for transmission line protection as compared to transformer, because the length of transmission lines is high. Also, installing and maintaining the pilot wire over long transmission line can be costly and challenging. For long line, the charging current resulting from the pilot wire capacitor may enough to trigger the relay operation even under normal condition. Capacitor is formed between the ground and the pilot wire. Due to this, charging current is flow through the relay, and under balance condition, this charging current may operate the relay. The system is not suitable for line voltage above 33 kilovolt due to the construction challenge in matching the current transformer. So, this is all about the different protection technique which we covered for transmission line protection. So, the overhead transmission line has a greater fault incidence rate than the other crucial component of electrical power system because of mostly exposed to the atmosphere and their greater length. Transmission line fault are traditionally divided into two categories, series fault and shunt fault, or protection scheme is divided into two categories, unit and non-unit protection. Under the unit protection, we have covered the differential protection technique, and under the non-unit protection, we have covered the time graded overcurrent protection and impedance type distance relay. Time graded overcurrent protection is a method used to protect transmission line by coordinating the operation of protective device so that the device close to the fault operate first. It minimizes the impact of fault on a power system. Impedance type distance relay measure the impedance between the relay location and the point where the fault is incident and compare this impedance to the set value of impedance. If the measured impedance is less than the set value, the relay operate and isolate the faulty section. In actual practice, it is not possible to obtain instantaneous protection for complete length of line due to inaccuracy in relay element and instrument transformer. This difficulty is overcome by the 3-zone distance protection scheme. 3-zone distance protection is an effective and reliable method for protecting transmission line by dividing the line into 3 zones, each with its own reach and time delay. This scheme ensures quick and selective fault clearing while providing essential backup protection. Under the unit protection, we covered the differential pilot wire protection. Under that scheme, we have discussed about the merge price voltage balance system. Under healthy condition, current entering and leaving at one end is equal to the current entering at one end is equal to the current leaving at other hand. Therefore, equal and opposite voltage are induced in the secondary of CT at two ends of the line. The result is that no current flow through the relay. When a fault occurs, it will cause a different current to flow through the CT. Consequently, their secondary voltage become unequal and circulating current flow through the pilot wire and relay. So, this is all about the different protection technique which we discussed in the transmission line protection. In next lecture, we will cover about the protection technique which we will use for the rotating machine. Thank you all for your listening.